Welcome back to Rice.AI Code Room. Today we are tackling LeetCode 2075, Decode the Slanted Ciphertext. The problem gives us an encoded string and the number of rows used to encode it. The original text was written into a matrix diagonally, starting from the top left. Then, the matrix was read row by row to produce the encoded string. We need to reverse this process and return the original text without any trailing spaces. To decode it, we first calculate the number of columns, which is simply the length of the encoded string divided by the number of rows. Since the encoded text is formed row by row, the character at row R in column C is located at index R times columns plus C in the encoded string. Our thought process is to read the characters diagonally, just as they were originally written. We iterate through each starting column of the first row. From each starting point, we move diagonally downwards, incrementing both the row and column until we hit the boundary. Let's look at the implementation. We find the length of the encoded text and compute the columns. We use a nested loop where the outer loop iterates over the starting columns, and the inner loop traverses the diagonal. We append each character to our result string. After extracting all characters, the problem states there should be no trailing spaces in the original text. So, we simply use a while loop to pop off any trailing spaces from the end of our result string. Finally, let's talk about complexity. The time complexity is O of n, where n is the length of the encoded string, because we process each character exactly once. The space complexity is also O of n to store the decoded result. Thank you for watching.